Okay, in this session we're going to look at order of operations and solving equations. So when solving equations, we're aiming to find an unknown value or variable by rearranging the terms of the equation. Alright, so for example, x plus 5 equals 8. If I have this as an equation and I want to solve for the value of x, well, x here is the variable, and I need to rearrange this equation so that it says x equals and then gives the number, right? So to do that, in this case, I would subtract 5 from both sides. So I have x plus 5, then I subtract 5 from that side, and I have to do the same thing on the right-hand side. Okay, and then you want to simplify. On the left, 5 minus 5 is 0, so we have x plus 0 is x. And on the right-hand side, we have the answer. 8 minus 5 is 3. Okay, so that's a very simple example of solving an equation. Now, when we perform steps, and in particular, when we see something like 3 plus 2 divided by 5 minus 8. This, for example, if we see something like this, we need to simplify this using the order of operations, all right? Well, sometimes you see this sort of thing in an equation as well, but it's more common just for the purpose of simplifying an expression that you might see. Okay, so that order of operations is first, number 1, brackets. So if we're to do that here, we would tackle these brackets first. Okay, so let's go ahead and do that. This is step number 1. Would say that 3 plus 2 is 5. Okay, the next one, exponentiation, or taking powers, right? So for example, 2 to the power of 3 is the exponentiation of 2 to the power of 3, right? So that would occur in the second order, right? So after you do the brackets, you would do the exponentiation. Okay, so once you've handled those two, you do multiplication and division from left to right, right? So they have the same order in the order of operations. So you take those from left to right. Now, so if I did that here, I would just be doing 5 divided by 5 is 1. And so I would get that this is 1 minus 8. And then finally, with equal preference, addition and subtraction, right? Where you do this as they appear from left to right. So if I were to simplify this, that would be the last thing. I have 1 minus 8 is minus 7. Okay, so bracket 3 plus 2 and bracket divide 5, take 8 is minus 7. Now there are a number of other ways to remember this. It's handy to remember this through an acronym like BEMDAS or BOMDAS. Now the O in BOMDAS would be order, and that's just another word for powers, taking powers. But you could equally well say BEDMAS or BEDSMASA, something like that. This one's not very useful because it doesn't sound memorable, but BEDMAS perhaps. And that is to say that multiplication and division, it doesn't matter which one is done first, so long as it's done left to right. Okay, so you take those left to right, they have equal importance in the order of operations. The same with addition and subtraction. Alright, so let's go into a little bit more details on solving equations. Given an equation or an algebraic expression, we usually need to simplify it, which means rewriting it in a simpler form. So we do this by following the order of operations. So once you've done the brackets, exponentiation, division, and multiplication, you would collect like terms, grouping those together, and then you perform the addition and subtraction of the like terms. Alright, so let's just choose an arbitrary algebraic expression. So 2x plus y, and then plus 3x and then let's say all of that in brackets times minus 5, and then we'll say plus 8. Okay, so if we were to simplify this using the order of operations, we would do the brackets first. Alright, so let's go ahead and simplify this now. So that means we're collecting like terms. Now we have commutativity of addition, meaning that a plus b is equal to b plus a, so we can move these like terms around and group them together, being collecting like terms. Alright, so doing that, our next step is to simplify the 2x plus 3x, and we get 5x. So we have 5x plus y in brackets times minus 5. Okay, so our next thing to do here is the multiplication. So we have a multiplication, we have an addition, but multiplication takes the first priority. We don't simply add the 8 and the minus 5 because we have a multiplication in there, and we should do that first. So simplifying this then would mean that we multiply that 5, distributing it over the sum, and we have minus 5 times 5x, and then plus minus 5 times y, and then we still have the plus 8. Alright, so we've expanded, distributing that minus 5 over the addition there. So now we need to simplify those two products that we have on the left. Minus 5 times 5 is minus 25, so that is minus 25x. And next we have minus 5y, and then we have plus 8. Alright, so we've used the order of operations here to simplify this algebraic expression, and this is more or less as simple as it gets, right? Without going backwards and factorizing. Okay, so let's move on to the next topic, solving simple equations. Alright, so to solve the equation, now I'm going to follow along here and rewrite this. Whoops, I've just opened Zoom. I don't need that open. So we've got 7 and then brackets 2 plus 3x. That's over 4. Equals 5x minus 6. Alright, so we want to solve for x here. X is our variable. So we have a look at this equation, and we've got a choice, right? We could simplify this on the left and then collect like terms, but it's probably easier if we first multiply throughout, that is left and right side, by 4. So I don't change the equation by multiplying the equation by 4, meaning multiplying both sides by 4. So multiplying by 4, what we'll have then is 7 times 2 plus 3x, right, because the 4's cancel on the left. And then on the right hand side we have 4 times 5x minus 6, right? Okay, so having done that, it seems like it would be a good idea to expand both the left and right hand sides at this point. So let's go ahead and do that. So the multiplication of 7 times this bracket, it should distribute over the addition. And so what that means is that the left hand side is 7 times 2 plus 7 times 3x. And the right hand side is 4 times 5 minus 4 times 6. Or you could say this last part as plus 4 times minus 6 in brackets, right? But the product is the same. You get minus 24. Alright, and I seem to have missed an x here, so I'll put that back in. Alright, so next we want to simplify those multiplications so then we can put things on the same side of the equation, collect like terms, and finish it off. So let's go ahead and do that. So we have 7 times 2 is 14, 7 times 3 is 21, so that's 21x. Okay, on the right hand side we have 20x minus 24. Alright, we're nearly there. So next what we need to do is move the x's to the same side of the equation and the constant terms to the same side of the equation as well. Alright, so we probably want to take the 20x over to the left because that would give us 20 21x minus 20x is 1x, which is positive, and that's nice, but you don't have to. You could have gone to the taken the 21x over to the right-hand side. It just gives you an extra step. All right, so let's go ahead and collect like terms in that way. So what we're doing now is we're subtracting 20x from both sides, right? So I have 14 plus 21x minus 20x equals 20x minus 20x, and then we still have the minus 24 there. All right, so on the right-hand side, you'll see that the 20x is vanished. We have 20x minus 20x is no x's, 0x. And that was the whole idea, and which is why I said, let's move it over to the other side. But we're obeying the laws of algebra here, right? What we do to one side, we must do to the other side. So then we have 14 plus, now this simplification of 21x minus 20x is just 1x. So 14 plus x, and then on the right-hand side we have 0 minus 24, but we may as well just write minus 24. Okay, in the last step we want to move the 14 over to the right-hand side so it leaves x isolated, and so we'll say x equals a number. Alright, so let's go ahead and do that, but what we do in this process is we subtract 14 from both sides. So 14 minus 14 plus x equals minus 24 minus 14. Okay, now on the on the left-hand side we have 14 minus 14 is 0. That was the whole idea. And that just leaves x on the left. And on the right-hand side we have minus 24 minus 14. Now that is minus 38. So x is minus 38 here. Alright, now I could take another little check step here and get the computer to do the same thing, but I've got to write a little piece of code, which is just a word, and say what I'm solving for, and I can check this. Okay, you can see it gives me x is minus 38. Now you might be asking, how can I use this? Well, you could open up a website called www.wolframalpha.com. Alright, and you can ask plain text questions of a mathematical nature. Right? It'll give you several kinds of responses, and you sort of have to piece it together yourself to understand that. Right? Now, don't use it to do your assignments. Don't use it to do your exams. Definitely, it's advisable to use it as your own personal tutor for when you need to check things, you need to check your reasoning. It's not a bad idea to use it, right? But definitely do not use this for assignments or exams. You need to submit your own work. And remember, you're going to do several mathematics courses, right? Because you're probably doing an education degree or an engineering degree or a science degree. You're going to need the mathematics in this course, right? So you must learn how to use these tools yourself and master them, right? This is a foundation level here. All right, so let's have a look then at our next example. Oh, and incidentally, you can check this by hand just by substituting in minus 38 into the expression and checking that you get 5 times minus 38 plus 6. All right, so that would be, now if I'm going to check this with the computer's help here, I'm going to ask the computer to simplify this expression, and to do it, it would use the order of operations. So let's just check the left-hand sides and see if they're the same when we sub in minus 38. Yes, they're both minus 196, and so they're the same thing. So it works, right? So we've checked that minus 38 is a solution to the given equation. Okay, so let's move on to example 2.2, where it says solve the equation 3 in brackets times 4 minus n is equal to minus n, and we're solving this for n. So I'll rewrite this and talk about this along the way. 3 times 4 minus n is equal to minus n. So we want to solve this for n. Okay, so on the left we've got a number multiplying by something in brackets, and we want to solve this for n. We've got n on the left hand side and on the right hand side, so it's probably a good idea to expand here, right? Otherwise you may end up going in circles a little bit before you finally get to an answer. Okay, so let's expand. So we're using the fact that multiplication distributes over addition, right? And that's the way I remember this. Of course it distributes over subtraction as well, but subtraction is the additive inverse of addition, and so in a sense we think of addition and subtraction as the same operation. So subtraction is just adding the negative of the number. So 3 times 4, and then we have plus 3 times minus n is equal to minus n. All right, so we've distributed that multiplication over the difference there, or the addition, as I said, in the sense that they're essentially the same thing. They hold the same order in the order of operations. Okay, so next we want to simplify those two multiplications. So we have 3 times 4 is 12, and then we can write 3 times minus n as minus 3n. And then this is still equal to minus n. Nearly there. Now we want to collect like terms. Seems like a good idea to add 3n to both sides. Now, as I go through these problems, I'm going to display fewer and fewer steps, okay? So I'm going to say, taking the minus 3n over to the right-hand side, but there's a process. You would be adding 3n to both sides. Okay, so doing so, I have 12 equal to minus n plus 3n. Okay, so we want to collect those two like terms, add them on the right hand side. So we've got 3n minus n is 2n. So 12 is 2n. And now the last step is to have a look at the 2 and the n. What are they doing? They're multiplying together. So what's the opposite of multiplication, as in inverse operation? It's division. So what we would want to do here is divide both sides by 2. Alternatively, you can consider this as multiplying both sides by 1/2. Alright? So if we do that, then we have 12 times 1/2 is equal to 2n times 1/2, which we know is n, or 1n. Alright, but this here on the left is the same as 12 divided by 2. Okay, so what we get then is that 6 is equal to n, but we want to write this as n equals 6. Because remember, we're solving for n, so we want to put the n on the left. It just sounds better. And that's all. Okay, so let's move on now and have a look at another example. Example 2.3. Solve the equation, and I'll rewrite this and do the same thing. 5 minus, in brackets, x plus 2 equals 5x. Alright, we want to solve this for x. Now look at what's going on there. We've got x on the left and the right hand side, and x is inside a bracket. So we need to deal with that bracket first according to the simplification of the left hand side, and multiply the minus 1 that's in front, right? Because we couldn't view this as minus 1 times this. And so we want to distribute that minus 1 over the addition. Alright, so doing that, we have 5 minus x, or minus 1 times x, plus minus 1 times 2, which is minus 2. Okay, equals 5x still. So next we can simplify the left-hand side a little bit more. And we'll say 5 minus 2 is 3, so 5 minus x is 5x. Okay, our almost last step is to collect the x's on one side of the equation, and doing that involves adding x to both sides. Right, so let's add x to both sides, and I would say just moving the minus x over to the right hand side. So we have 3 is equal to x plus 5x, and that's 6x. So I can say, swapping sides now, 6x is 3, and if I divide both sides by 6 so that I have x isolated on the left, we've got x is 3 over 6, and we can just call that a half, reducing that fraction. So 3 goes into 6 2 times, or you can view 3 over 6 is 3 over 3 times 2, and then cancel the 2 3's in it, and you're left with 1/2. All right, great. So if you have any questions, you can leave questions in the comments, and if I've made an error or a slip up, you can note that too. All right, let's have a look at example 2.4. Solve the equation, and I'll rewrite this again. 2x is equal to, now we have a fraction here, minus 5 in brackets, 7 minus 3x, then we have plus 2, and that's all over 4. Okay, so we want to solve this equation for x. Now it seems reasonable to multiply both sides by 4. Of course, you don't have to do that. If you instead decided to break this up, you could have broken this up and said that that's minus 5 bracket 7 minus 3x over 4 plus 2 over 4, and then expand that part and collect like terms. You would hopefully get the same answer, and I say hopefully because, you know, potentially two people could make an error and have a disagreeing solution, right? So a linear equation, and this is a linear equation because it only has powers, the powers of the x's are just x to the power 1. So this is a linear equation. This linear equation has one solution. All right, so a linear equation in one variable will have one solution. All right, so like I said earlier, it's advisable to multiply by 4 on both sides. So 2 times 4 is 8. So we've got 8x is equal to, what is on the numerator here? All right, so our next step should probably be expand this bracket, distributing the minus 5 over this difference here. So then we have 8x is equal to, let's put that in brackets, minus 5 times 7, and then plus minus 5 times minus 3, and then there's an x there, and then we have a plus 2. Okay, now you can see here in the PDF file that I've written this slightly different. These are the same thing, right? So over here I've got minus 5 times minus 3x. These three are all multiplying together, so associativity of multiplication says it doesn't matter in which order we take that product, we'll get the same thing. Okay, so next we want to simplify this expression that's on the right hand side. Minus 5 times 7 is minus 35. Minus 5 times minus 3 is plus 15. We still have that multiplying by x. Remember, x is unknown. We're solving for x, and then we still have plus 2. Okay, so on the right hand side we can simplify 2 minus 35 is minus 33. So let's go ahead and do that. And we can put that in the back if we like. Hang on, equals 15x minus 33. It just saves writing another addition in that expression, right? And it looks better. Okay, so next we may want to take the 15 over to the left-hand side, or we could take the 8x over to the right-hand side and at the same time take the minus 33 over to the left-hand side. So that's what I'll do. I'll take the 33 over to the left-hand side. It becomes a plus now because remember I'm adding 33 to both sides. And the minus 33 will vanish when I do that on the right-hand side. Now, at the same time, we can subtract 8x from both sides. Okay, and now we need to simplify. So 33 is equal to 15x minus 8x, which is 7x. And then we can divide by 7, and we have that x is equal to 33 over 7. Now if you look at the PDF there on the left, you can see we have minus 7x is equal to minus 33. So in that attempt at solving the equation for x, we went the other way. So we would have taken the 15x over to the left-hand side and left the minus 33 where it is, right? So you would get that. And so there is another step when you do that. You would have to divide by minus 7. But of course, this is the same thing as minus 33 over minus 7, because this is, let's set this out, we have minus 1 multiplied by 33 over minus 1 multiplied by 7, right? And you can cancel the common minus 1 in the numerator and denominator, just as you simplified the fraction 3 over 6 and wrote 1/2. All right, let's move on. All right, so here's another little piece. You can approximate that if you want to, right? Now, 33 over 7 is the recipe for that rational number. A rational number is a number that can be expressed as a fraction where the denominator is non-zero. And with rational numbers, we know we can always cancel common factors to write that in its lowest form. Right? But we can approximate 33 over 7. Let's do this while we're at it. On the computer here, 33 over 7, I'll put in a 7.0 so it gives me a decimal number. All right, so we have 4.71429, and this will go on, and because it's rational, we know that it's going to repeat its decimal expansion at some stage, right? In fact, let's go ahead and get a longer expression for this. I'll say, let's give me a numerical expansion for this. Let's say 20 decimal places. All right, and let's look for a pattern in the decimal expansion here. We have 4.7142857. Okay, and then we have 142857, but it's repeating after the 5. You see that? 714285, 714285. Okay, so you could represent this as 4.7142885, and incidentally, to show that that pattern repeats indefinitely, you would put a little bar over it. Let's see if I've got a button for this here. Maybe this? No, that's the wrong way. And you know, something like this, but that looks like a dash line. You put a solid line over it to say that piece of it continues. All right, while we're at it, I'm going to show you another trick here. Suppose that you have this number, right, and you know that this thing repeats, right, every 6 decimal places. All right, so let's call this number S. All right, if I call that number S, and I'll put here ... to say it continues in that pattern. Okay, now if I multiply this number by, let's see, 10 is 10 to the 1, 100 is 10 to the 2, so am I multiplying this by, see, I have 5 zeros behind the 1, right? I think I want to multiply this by 100,000. And actually, let's just put that into memory and see if that did the trick. Not quite, right? I need to multiply this by, let's see, another 0 gives me this. I need another 0 yet. So, yeah, I wanted to multiply this by 1,000,000. Okay, good. And the reason I wanted to multiply this by 1,000,000 is so that we have the end being 0.714, and it's the same thing. All right, so I'm going to cut the calculation there, and let's clear that from memory so I can pick up where I left off. And I'll just say, because I now know what this is. All right, so we'll put back in the dots. And we have moved this over to here because we've multiplied by 1,000,000. All right, and let's stretch this out. So that's just on one line. Okay, so I multiplied s by 1,000,000. And now think about what would happen if I subtracted 1,000,000 s minus s. All right, so let's do that. So 1,000,000 s minus s is equal to this number, take away this number, and what happens? The part after the decimal place, they're exactly the same, right? So what we have there is then that this is the same as this integer take 4. Because the decimal part, the part after the decimal place is the same, and therefore those will vanish. So what we have then is that, and then we can simplify the part on the left as well, why don't we? Okay, so this is how many nines? 6 nines. And then 5 minus 4 is 1. Okay, and so s is equal to the fraction 4714 over 6 nines. Let's see, does that reduce? Yes, it reduces to 33 over 7. So there's a theorem that says that any rational number has a repeating decimal expansion, and any number that has a repeating decimal expansion is a rational number. So, and this is the process for finding out which rational number it is. All right, so this is just for interest's sake. So let's go back to solving equations, and I guess there was an equation here that we solved, right? Because we simplified this, we divided both sides by 999, 999, and then reduced the fraction. So I think that example was not far from appropriate. All right, so let's continue on here. Example 2.5, solve the equation lowercase v is uppercase v times n plus uppercase m all over lowercase m, and we're solving this for uppercase m. So I'll go ahead and rewrite this so I can talk about it along the way. M plus m over m. Oh, that's an n upstairs in the numerator. Okay, great. We're solving this for uppercase m. So what we'll want to do is multiply both sides by lowercase m, right? So that we clear that fraction. And when we do that, on the right hand side, the lowercase m will cancel. But to do this, to move it over, we need to multiply by lowercase m. So that's lowercase m times lowercase v is equal to uppercase v n plus uppercase m. Now, remember, we're trying to solve for uppercase m. Okay, so at this point, we have a choice. We can expand the right-hand side and then seek to solve for uppercase m. In the PDF, I don't do that. Instead, I divide by uppercase v. That's fine too. So if we divide by uppercase v, then what we have, and we're multiplying by 1 over uppercase v on both sides. So we have m lowercase v over uppercase v equals n plus uppercase m. Alright, so now it looks simple to solve for uppercase m. All we have to do is subtract lowercase n from both sides. So I can pretty much rewrite this and say here we have minus n and here we have the equal sign. Right? So in other words, subtracting n from both sides, we have mv over uppercase v, all take n is equal to m. But remember, we're solving for m, so it's nice to write that on the left side of the equation. So it says uppercase m equals this expression here involving everything else. All right, now look on the PDF. I've done some simplification. Have I? Or have I got, no, I've got a mistake there, haven't I? Yes, looks like I've got a mistake in the working out because what I did was copy down the problem incorrectly. All right, so seems like I copied down the problem incorrectly. So this would be the final answer here. Now you could make this be all over uppercase V if you wanted to. So let's go ahead and do that. And so that means I'm factorizing out of the right-hand side 1 over V. Right? Now this is a little bit tricky. So I can easily factorize 1 over uppercase V out of the expression on the left. And what I have remaining is m lowercase v. But on the right, if I were to factor out 1 on v out of n, I would have to introduce an uppercase V there. Just like that. Alright, so now you notice if you expand this back out, you get exactly this. And so these two things are the same thing, right? Now, does it matter? Do you need to do this extra step? No, not really. Not really, you don't. But yeah, sometimes it's convenient to factorize something out of it, right? So that, I just want to expose you to all the necessary tools so that you can be a master of solving simple linear equations. All right, but let's note, so you should write on your own page, if you've printed out this document, you should write out that I copied down a typo, and so what you have here in the video is actually what you want to write. And I can see there's space to do that in the column. So you can write out, Sam accidentally copied down the wrong problem, right, where I copied down M here rather than N. Hey, it's easy to do, right? Okay. So let's move on to example 2.6. Solve the equation. Now that's lowercase p over uppercase P equals AI over B plus AI for B. Okay, I want to write this out again. And I suppose writing it out again can help me pick up on typos in the notes here, which is not a bad thing. P over uppercase P equals AI over B plus AI, and we're solving for B. Alright, now we've got a choice here. We can multiply both sides by what's in the denominator so that it's easier to solve for B, because that would put B up in the numerator. Another choice would be just to flip or invert both sides. Right, but I feel that in an early stage of your algebraic education, that might be a more risky move. You might be more likely to make an error. So let's just follow what we have there on the PDF, and we'll multiply both sides by B plus A times I. Alright, so doing that, we'll have lowercase p over uppercase P times B plus AI. Now we can put that in front of the fraction, or we can even put that in the numerator. We have the same thing. Okay, so what are we solving for? We're solving for B. So now what we would want to do is maybe put the uppercase P over on the right-hand side, and doing that involves multiplying both sides by uppercase P. So then we would have P bracket B plus A times I equals A times I times uppercase P. Alright, so we can choose now, do we want to expand this bracket and then solve for B, or do we want to divide both sides by lowercase p? That might actually be easier. But let's go ahead and do the same method that's in the notes here. So in the notes we have expanded the bracket on the left, so then that would give us P uppercase B plus P uppercase A I equals A I uppercase P. Alright, we're seeking to solve for B here, so we want to take everything else over to the other side, and to do that we need to subtract PAI from both sides. So that's lowercase PAI, and that gives us PB equals AI uppercase P minus lowercase p ai. Looks like we can do a little bit of simplification on the left because we can factorize. We have a and I common in both of these terms. So if we were to factorize that, we have lowercase p times b equals, now ai is common in both, so we can pull that out. What's remaining is uppercase p minus lowercase p. We're almost done. We need to solve for uppercase b there. But it's multiplying by lowercase p, so we need to apply the inverse operation, which is divide or multiply by 1 on lowercase p. And so doing that, we have b is equal to this right-hand side over lowercase p. All right. Now you could divide that into the uppercase p and the lowercase p, and so you'd have uppercase p over lowercase p, take 1, still in brackets, times ai, or you can do like what we have here on the PDF and say that it's ai over lowercase p and then brackets uppercase p minus lowercase p. All right, same thing. All right, let's move on to the same section here. Formulating and solving word problems in algebra. So a lot of students will struggle with these types of problems, and I think the hardest part of those problems is reading the problem and translating that to some mathematical equations. Personally, so that's a little bit of a struggle, but personally I think that solving the equations that you get is the easy part, right? And I hope you find that to be the easy part too. Whatever you find difficult, you're going to need to practice. All right, so let's read this question. So here's some advice on the steps, right? Identify the variables that are needed. You got to give those names. Determine the relationships between the variables. Write the relationships as an algebraic equation. Solve it, interpret the solution, and then write it in the context of the problem. All right, so let's have a look at this example 2.7. A delivery firm uses one fleet of trucks on daily routes of 8 hours. A second fleet with 5 more trucks than the first is used on daily routes of 6 hours. Budget allotments allow for 198 hours of daily delivery time. How many trucks are in each fleet? All right, so we set out our letters. We let X denote the number of hours on the route of 8 hours. Then the number of trucks on the route of 6 hours is 5 more than that, which would be X plus 5, right? So you could set this out in a somewhat different way as well. So you could say let X denote the, just as written there, number of hours on the route of 8 hours. Okay, then you could say let Y, and I've written denote wrong, so I'll fix that. Let Y denote, and I'll just copy and paste here because I can, but I'll change this to 6 hours. So Y denotes the number of hours on the route of 6 hours. Okay, so the next sentence is the number of trucks, oh hang on, let's reread this. Like I said, it's tricky. 5 more trucks than the first. Okay, so that is definitely the number of trucks. The number of trucks on the route of 6 hours is X plus 5. All right, so then I can't make the statement that that's Y equals X plus 5 because it's not true. Anyway, so the total number of daily hours of delivery time is 198. We're told that in the problem, which is 8 times 8 times X, and then we have 6 times X plus 5. All right, so this is the equation that we need to solve. So what we want to do here is simplify the right-hand side. So 198 equals 8x plus 6x plus 6 times 5 is 30. Okay, so now if we add 8x and 6x, we have 14x. And then we can subtract 30 from both sides, and we'll have 198 minus 30 is equal to 14x. Okay, so that then says 14x is equal to, what's 198 minus 30? It's 168. And finally, we need to divide both sides by 14. So x is equal to 168 over 14. And so you can do some of this in your head, or you can use a calculator. So 168 and 14 are both even, so you can easily cancel a 2 from both sides. Right, so then that would be, let's see, what's half of 68 is 34, so 34 and 50 is 84. Right, so you've got 84 over 7, all right? And so that simplifies to be 12, because 12 times 7 is 70 plus 14 is 84. All right, but you might like to use a calculator. Okay, so we've got 12 trucks are used on the 8-hour route, and 12 plus 5 trucks, which is 17 trucks on the 6-hour route. All right, now in the next example, I think I treat this somewhat differently, and somewhat differently than Lauren does, because I want to give you the opportunity of viewing this in a slightly different way as well. Okay, so let's read this one. A computer chip manufacturer produces 2 types of chips. In testing a total of 6,100 chips of both types, 0.5% and 0.8% of the other type were defective. All right, so 0.5% of the first type and 0.8% of the second type were defective. If a total of 38 defective chips were found, how many of each type were tested? Okay, so let's let X denote the number of chips of type 1 and Y denote the number of chips of type 2. Since the total number of chips tested is 6100 or 6,100, we have the sum of those two has to be 6,100. So X plus Y is 6,100. Great, that's one equation. Now, 0.5% of X is 0.005 times X. Okay, think about this. What is 0.5% of 100? All right, well, 5% of 100 would be 5. And so 0.5% would be 1/2. All right? So in other words, what you have to do is you have to multiply the number and then divide by another 100, or move it 2 decimal places over. So 0.5% of X is 0.005X. 0.8% of X is 0.008Y. It follows that the total number of defective chips can be expressed with the equation. So remember, that's 38 chips were defective, and what we have here is the number of chips of type 1 that are defective and the number of chips of type 2 that are defective. So they've got to add up to 38. Okay, so we have 0.005x plus 0.008y equals 38. Great, that's awesome, because now we have simultaneous equations. They're linear, so this should be pretty easy to solve. And I'll say here, most of this course is linear algebra, and this shows you, this is one of our first examples of linear algebra, which is often about solving systems of linear simultaneous equations. But it covers other topics too, like vectors, matrices, and so on. Okay, so what you probably know at this point as to a tool for solving simultaneous linear equations is the method of substitution. Right, so let's just pretend that that's all we know for now. That's fine. There are other methods. We'll learn those soon. Okay, so what you might want to do is solve the first equation for y. And if we do that, we then have y is equal to 61, 6100 minus y, we're subtracting y from both sides, or sorry, x from both sides. And then you take the other equation, 0.005x plus 0.008y equals 38. You take that equation and you replace the y's with what you've solved for in the first one. All right, but do that with a bracket here. So we'll sub that in, putting a bracket in. Now you have to simplify it and expand that bracket, collect like terms, solve the linear equation in one variable, right? So this, at this point, this is what we've done up to this point. Okay, so let's go ahead and expand the left-hand side so that we can collect like terms. So this would be 0.008 times 6100 and then minus 0.008x. Okay, so we've distributed that multiplication over the difference there. Now we want to take the product, this product right here. Let's get the calculator to do that. Okay, we get 48.8. So I'll rewrite this on the next line. And we'll put 48.8. And you can see there that puts... Now incidentally, this is an error in the computer's calculation there. It's because, and when this happens, you should probably read this still as 48.8, right? So what I've done is I've copied this and I've pasted it up here, but the computer's taken that product up to so many decimal places and then it's got an error at the end of it, right? So you've got to view this for what it is, right? So we know that that's 48.8 there. Okay, so next we want to collect the two like terms that have an x next to them. So let's take this, and by commutativity of addition I can swap that around, move the order around, and then we can add the two of these. Okay, so 0.005 minus 0.008 is negative 0.003. So that part there will then be minus 0.003 times x. Okay, let's take the 48.8 over to the right-hand side. And then let's simplify the right-hand side. So we need to probably put that in the calculator, or you could just see that that's minus about 10, but let's do it with the calculator. Minus 10.8. And again, we have to interpret this according to what it's supposed to be clearly. It's minus 10.8. Okay, so we're nearly done. It just remains to divide by the coefficient of x. That's the number next to the x, multiplying by the x. And so we need to divide both sides by minus 0.003. Okay, so x is equal to, and now I'll put a bracket in this because of the way I'm going to write it, divided by minus 0.003. And the reason for putting the bracket in is because we've got a negative divided by a negative, and we want to be careful with this, right? Okay, we know those two negatives will cancel. Minus 1 divided by minus 1 is 1, so the result will be positive. So you need to then punch into your calculator, what is 10.8 divided by 0.003? Okay, I'll do that here. We've got 3600. Okay, so x is equal to 3600. And I can leave that just as the integer there. All right, great. So let's move on. And in the last step, you could check this, and by check, sub x in. Of course, you want to find y as well, so let's go ahead and do that too. We're not quite done. So y is equal to 6100 minus x. So this is 6100 3600 minus 3600, and let's calculate this. So we have 2500. Okay, and then finally you want to interpret what these variables equal something mean in the question. In the context of the question, what does it mean? So 3600 chips of type 1 and 2500 chips of type 2 were tested, right? So you should write an answer to a word question in the context of the question that it was posed. So in words. Answer it in words, all right? Just like what I've spoken here and written down on the page. Okay, moving on to example 2.9. An outboard engine used a gasoline oil fuel mixture in the ratio of 15:1. How much gasoline, and if you don't know, gasoline is just petrol, it's an American way to say petrol. How much gasoline must be mixed with a gasoline oil mixture, which is 75% gasoline, to make 8.0 liters of the mixture for the outboard engine? Now, just reading that looks like an extremely difficult question, but in reality, it's not that hard. You just apply the steps, identify what the variables are, think about it, go line by line and see if you can write down some algebraic expressions, right? So the proportion of gasoline in the mixture is 15 to 15 plus 1, right? So think about that. So the gasoline part of it is 15 in the ratio of 15:1. So the numerator is 15 and the denominator is the total, so 15 plus 1. So the proportion is 15/16 in the mixture. But here we're asked to make a different mixture, right? A mixture that has 75% gasoline rather than, let's just calculate this as a percentage while we're at it. So rather than 93.75%, right? So we start with a gas mix that is 93.75% gasoline, petrol. And we seek to make a mixture that is, what did we say, 75% gasoline. All right, so that's the problem. Okay, so let's let X denote, so X is the quantity in liters of gas. Y is the quantity in liters of gas oil mixture that has 75% gas. All right. Okay, so it's tricky, yes. In the final outboard engine mix, all right, that's the end of the sentence. So we have X plus Y is 8. Now, why is that? Where's the 8 in the question here? All right, so X, remember, is the quantity of gas in liters in the final mixture. Y is the quantity in liters of gas oil mixture. I'll put that in brackets so it's clear to read. All right, and so this is in the final mixture, right? So we're reading this sentence here, the second sentence. So that adds up to 8. So that's X plus Y is 8. All right, this is a volume that we're adding up. And the proportion of gas in the mixture, okay, so this will be in the original one. So then we've got X plus 0.75 times y, so that's a volume there, divided by 8 is equal to 15 over 16. All right, so maybe I misspoke the original question here, because it looks like, yes, I understand. Okay, so I'll rephrase that question. So what you're given here is, you're given a mixture that's 75%, and you need to make a mixture that's 93.75%. So this is kind of in the reverse order. So we start with a mix that's 75%. And we want to get one that's 93.75%, because that's what the boat takes, right? In other words, the 15/16. All right, so then this gives us this new equation. This is to be 15 over 16, and so we've got to solve this now as a simultaneous system of linear equations. Okay, great. So then now we're at the easy part, is just solving. So let's go ahead and do that. Now, if we were to take the second equation, simplify it a bit first, we might multiply both sides by 8, and we get x plus 0.75y is 15 over 16 times 8, but that's 15 over 2 because there's a common 8 to cancel. Okay, and now let's rewrite the two equations together. Alright, so if we solve this via substitution, then we solve the first equation for y, for example, and say that's 8 minus x. And we want to sub this into the second equation where we see y's. There's only one. Alright, and expand that and simplify it. So let's do that. X plus, what is 75% of 8? 0.75 times 8. So 0.75 is 3/4, so we can cancel a common 4. 8 divided by 4 is 2, so that's 2 times 3 is 6. And then minus 0.75 times x is equal to 15 over 2. Okay, simplifying the x's there, we've got 0.25x on the left, and we'll take the 6 over to the right hand side. Now half of 15 as a decimal number is 7.5. So 7.5 minus 6, so we can simplify that as 1.5, right? But let's go ahead and make this easy on ourselves. So 1/4 is the same as 0.25, so this is x over 4 is equal to 1.5, which is 3 over 2. Now you don't have to, you could punch into the calculator and that's fine. Okay, now I can just multiply both sides by 4, and we've got x is equal to 3 times 4 over 2, which is 3 times 2 is 6. Okay, so x is 6 liters of gasoline. And then we can back substitute into, say, this equation. 8 minus 6 is 2. So y equals 8 minus 6, which is 2 liters of the mixture. All right, and then finally you want to write your solution in words. Something like, it follows that we must use 6 liters of gasoline and 2 liters of the gasoline oil mixture to make the mixture for the outboard engine. All right, and that brings us to our next chapter, which is week 3. So I'll see you for that.